was a way for them to reconnect with being a team member, a way for them to, to collaborate with people again, to build something, to have purpose. I've always just had that feeling about manufacturing where there's nothing more uniquely American than getting people together from different backgrounds, different skill levels, to get them all together to make something, build something together that impacts our quality of life.
Hi, everyone, and thank you for listening. I'm your host, Kerrie Jordan. Welcome to our show where we talk with business leaders driving the future of manufacturing. Today, I'm speaking with Rick Oppedisano, founder and CEO of Delta Bravo AI, which is a company based in South Carolina, and it provides an AI-driven software solution portfolio for smart manufacturing. It's an integration-first platform, so it works with existing technical infrastructures like Microsoft, AWS, and Cisco systems. The company is on a mission to demystify predictive model development and to transform operations for manufacturers by leveraging their untapped data wealth. I am really looking forward to this conversation because this organization, its AI portfolio, and its mission statement are all so intriguing. What is meant by untapped data wealth? What happens if you can start to leverage such an asset? All right, we're going to get into it and so much more. Rick, welcome and thank you for joining the show.
Appreciate the invite, Kerrie. Always a pleasure.
All right, well, to kick things off, let's learn about you. Can you tell us a little bit about yourself, your journey, and how you founded Delta Bravo AI?
Yeah, sure. So we started the company about 8 years ago. So we're a bit of an early entrant to the AI market, so to speak, right? And really, for me, it was just a great time in my career. So prior to this, I have founded other software companies. I've worked in turnaround situations. Directly prior to this, I ran a publicly traded company that had 26 subsidiaries in 24 countries that focused on data modernization. So my career has generally been spent in that world, generally been spent doing entrepreneurial things. And when I had the time to think about what I wanted to do next back in 2016, I guess I've always felt an attraction to manufacturing. My father ran the oldest functioning military manufacturing arsenal in North America, called the Watervliet Arsenal. It's built to serve the War of 1812, and it's still functioning today. And When I was younger, yeah, it's pretty wild. I mean, when I was younger, I remember, we would eat dinner and come home, and this is, the late 70s, early 80s, dating myself here. But, he would come home and we'd talk about how, these folks would come back from the Vietnam War, and these veterans would have a hard time just kind of getting back into society, and how working in manufacturing was more than just a job. It was a way for them to reconnect with being a team member, a way for them to collaborate with people again, to build something, to have purpose. I've always just had that feeling about manufacturing where there's nothing more uniquely American than getting people together from different backgrounds, different skill levels, to get them all together to make something, build something together that impacts our quality of life, right? And at the end, this is really kind of what tilted me to start the business and focus on manufacturing. Was, yeah, sure, I'm a technologist. Love it. I've been working on machine learning stuff for 7-8 years now, at least 9 years. But for the reason why we chose manufacturing is, honestly, I'm a bit of an American exceptionalist. I feel that our people should have the best technologies. The folks that are out there building these solutions that enable the quality of life that we've come to expect in this country, they deserve more, they deserve better. And that's what we wanted to do here. And so that was when the company started, 2016. We had a few wonderful early clients that were great to work with, folks like Rolls-Royce, folks like AccuWeather, folks like Atlas Copco, that really allowed us to grow in a way where, we learned how to screw this up. That's the first thing I always tell folks about, entrepreneurial stuff, especially if you want to work in a field that's kind of cutting edge. If you want to start something new in something new, you have to realize what you're signing up for. And in our case, that was a series of customers that didn't have any previous frame of reference, no pre-existing frame of reference around what they were buying, how much it would cost, what the impact on their resources would be, how ready they actually were to take advantage of this and bring this capability into their process. And so we learned a lot over the years. And to kind of conclude where we've ended up, listen, there's a lot of things out there that are data collection tooling, visibility tooling, things like that. And there's a million people working on that. But the reality is, in a manufacturing environment, the manufacturer's intellectual property, the thing that makes that company worth what it is the process. All of the value in a manufacturer is in the process. And so we started to really get into that and say, how can we leverage data to improve the manufacturing process in a way where the risk around people is lower? People can learn this faster. They can find more value and joy and purpose in the job. How can we reduce the amount of waste associated with the process using AI? How can we improve throughput? How can we reduce defects? This is the stuff where if you get in there and you really understand all the different factors that influence and affect a positive or negative quality outcome, and how and where you can communicate to those things to an operator in a role-specific way, simple, quick, where you can tell them what to do in real time, that's what changes everything. People talk a lot about digital transformation, and they talk about upgrading a network or putting a dashboard in basic data visualization. Digital transformation, all that stuff that's just kind of like stuff around the edges. What we're talking about here is process transformation, leveraging AI as the engine behind that in a way that improves workforce readiness, improves operating margins, and reduces waste. So that's kind of where we've ended up.
I love it. And I love that you have really elevated the role of process and people across manufacturing. And you're right, manufacturing is so rewarding, such rewarding work. So that's great. Can you tell us a little bit more about Delta Bravo AI, the company and the solution that you have, and how is AI a part of it?
As you can imagine, when you bring in a manufacturing environment, there's what we would call like a holy grail of data sets. Okay. That's data from a machine, like PLC data. That's data from quality checks. That's data from an ERP system, like an Epicor, right? Where we take information about a product SKU, who the suppliers are, what the recipe looks like. And bringing that data together is complicated. All right. The machine data is time series. It can be 3 times a second. Then you've got a quality check that might happen 1 time an hour. And then you've got this recipe data, this ERP data that could be, 1 time period. Right. So, so there's a lot of stuff there that you have to put together. And so what we've done is we've built a platform that allows us to ingest that data, put it together in a way that very quickly can help us understand the influencing factors on a production outcome. So, for example, Nucor Steel is one of our older clients, just have a wonderful project, done a lot of work with those guys. And what we've done, we put together their quality data along with their machine process data, the PLC data, along with their supplier and recipe data. And we've built an AI engine that predicts the run before it happens, and tells their operators in real time how and where to adjust certain set points that allows them to produce a higher quality product with less steel scrap, in between transitions from one product to another on the line. So that's really what we built. And I would say the secret sauce of what we have within our technology platform is the ability to take these models and these awesome outcomes that we can produce from the data and turn them into an interface that is built for each particular operator and each particular function. So imagine every manufacturer is like, they want their own custom suit, right? So what we built for Nucor is going to be slightly different than what we would build for BMW or a Rolls-Royce or a Toyota or whoever. And so, so for each of those customers, each manufacturer is going to want something slightly different. And then each role at the plant that uses this is going to want to see that data just slightly differently to make sure that it's a custom suit for their role. And that's really where I would say that's the big innovation for us, is that we very quickly can produce these custom suits in a way that happens, fast, accurate, easily used, scalable, affordable for the customer. Because that's the other side of this. You have to be able to find, an appropriate return on this investment. And this is kind of, when you think about, again, just going back to the I would say the heart and soul of what's made us successful, it's coming in and saying, think about AI as like a process optimization, right? Not a technology purchase, but a process optimization. And think about the impact, think about measuring that process optimization the same way you would maybe with a capital equipment investment, where we think about it like a triangle. When you buy capital equipment, the triangle is going to have 3 pieces on the triangle. The first piece is, how does this improve? How does solving this problem improve my operating margin? So can I reduce defects? What would that, how much money would that save? What if I reduce scrap by 5%? What does that do to our bottom line? So understanding that first, the problem that you want to solve and how you want to measure it financially. Then secondly is, how does this make the life of my workforce better? And that's a whole other thing we could talk about maybe next, because I would say that that's a really pressing topic. But how do we improve workforce readiness? By bringing the solution into our process, right? In the case of capital equipment, it's a process that is no longer manual, right? So therefore, you don't have to train them. In the case of AI, it's making someone make better decisions faster. How do we take that training cycle from 6 months to a day, right? How do we take the impact of attrition at that job level from hurtful to minimal, right? How do we create joy in that job and fulfillment and make that person feel like they're a bigger part of the team faster by doing things correctly the first time? And then lastly is, how do you scale that? So in the same way, if you buy capital equipment to automate these things, to improve the workforce, to improve that readiness and improve that output, how do you scale it across multiple products, multiple lines, and multiple plants? So that's really the way that we look at AI. We look at it as a process improvement. AI is just a tool. It's the manufacturer's process that is the true intellectual property that we're focused on improving, so they can create that competitive advantage. And think about it, right? If we're at Epicor and I say, hey, Kerrie, you're going to have higher margins. You're going to be able to do this quickly. Your people will be happier, and you'll be able to scale it. You'll be like, hey, man, that's a winner, right? Yep. So that's really what we're focused on.
So when you are having conversations with maybe a business leader who hasn't yet gone down this AI path, are they thinking about ROI? Because, I mean, the way that you just described it there, it does really help to make that business case. And I think as we're all evaluating AI in our businesses, Epicor included, it's, what is going to be the outcome? I also want to get to that point too about workforce, because that is very important. But first about ROI, and actually they're probably related.
Oh, it's definitely, they are together.
Yeah.
So I'll tell you the dark and dirty secret here, after working with 96 or 98, whatever, is we're pushing 100 manufacturers in the last several years. The dirty secret here is that they're scared. All right. And they're not scared of the technology. All right. They're not scared of spending the money. They are scared about the golden goose, which is the process. So the process is the golden goose. And very few of these manufacturers, especially at the executive level, very few of them want to venture into territory where they can be held accountable for adjustments to the golden goose. All right. And so that is the number one thing that we see. But here's the problem. The problem is that folks that have that mentality are now starting to be brought into checkmate. And the thing that's bringing them into checkmate is people. So we were talking a little bit earlier. We just had a board meeting recently here at Delta Bravo. And the former CEO of BMW is on my board. The CEO of Net Pharmaceuticals is on our board. We have a high-powered board that holds me accountable for understanding the macro conditions that are influencing industrial AI purchases and processes. They hold me accountable for understanding how those macro conditions translate into the micro of what's actually going on in a plant. And I'll share with you the same statistics we shared with my board.
Yeah, please.
For some of these studies. Here's a great example. So the average tenure of a manufacturing worker in 2019, the average tenure is 20 years. In 2024, it's 3 years. Okay. The average time in the position for a manufacturing worker in 2019, 7 years. 2024, 9 months. The average 3-month retention rate. Now, this is a critical number. So the 90-day number is huge in manufacturing. If you can keep an employee for 90 days, then you have a 90% chance of keeping them for the rest of the year. It's a pretty common metric. And so the average 3-month retention rate, the 90-day retention rate in 2019 was 90%. The average 3-month retention rate in 2024 is less than 50%. And so if you add this up and you say, okay, financially, this is kind of interesting because it costs anywhere from $20,000 to $40,000 to replace this employee. So over the course of a year, you could technically be paying for 2 to 3 employees to fill one employee's position, right?
Yeah.
And then you say, well, so how does that affect the process? And this is the checkmate section, right? This is the checkmate section of today's program for people that are afraid to look at AI and process improvement. 84% of manufacturers, according to the studies that we used to evaluate the macro of our business, 84% of manufacturers have seen a loss of experienced personnel negatively impact quality, efficiency, and productivity. Huge number. So if you look at this, you're coming to a head because bad quality costs more than ever. Scrap costs more than ever. Lower throughput costs more than ever. And you're paying more for people to do that to you,
Yeah.
you know?
Yeah.
So the end product here is a higher cost per unit. And we know that when manufacturers can't do, where manufacturers fall over is when their cost per unit is too high and they can't compete anymore. And this is when manufacturers get sold for pennies on the dollar, is that when their competitors who do have a better cost per unit, right, a more profitable cost per unit, those guys will look at these competitors that haven't, that are struggling with this condition, and they'll buy them for pennies on the dollar. We've actually had customers that hire us to put together frameworks that they could use AI to do, predictive quality and the type of things that we do. And they go out and proactively look for companies that don't have it, that are family owned or that are more manual, that haven't made that investment. And they're like, we can go buy those guys for pennies on the dollar, drop Delta Bravo in there, and we can improve our cost per unit by 25, 30%, within 2 years.
That's
and now
great.
all of a sudden we've got a highly valued asset that we certainly didn't pay a premium for. So there's a lot of dynamics in the field, really, and they're all being driven by this, the cost of materials, the fluctuating cost of materials, the fluctuating quality and supply chain, and then the variation in operator performance. These things are working together to create process variation. And what do you know about manufacturing? Process variation is the enemy.
Yeah.
And the enemy's the winner.
So where do you recommend people start when you're working with manufacturers who haven't yet started down this path of AI? Maybe they are in the early phases of digitization. Where do you recommend they start based on the lessons that you've learned?
So I can tell you this, just start. Number one, your data is never going to be perfect. This whole idea of there's two big mistakes that we see folks make. Number one is thinking that this is an IT project. This is a process optimization project. Your IT guys are there to make sure that data acquisition and data access is compliant and secure. They're there to mitigate risks. They don't want to support this stuff. They don't have the background to understand what it takes to tune and retrain a machine learning model and deploy this at the edge. IT guys should not run this project. This is a process project where IT folks should be there to mitigate risks around security and data access. So that's the number one mistake we see, is that when they let a technology person or an IT person guide what is a highly sensitive business project.
Mm-hmm.
That's number one. Number two is the relentless pursuit of perfection before progress, which is they're like, hey, this data is going to be perfect. We don't have enough data. Look, here's the reality. Your data was never collected with the intention to do this. This wasn't on people's radar when you bought that machine. This wasn't on people's radar when you set the specs for that machine, for what tags you were collecting, how frequently you were collecting them, or even how and when your quality checks took place. So the reality is, you don't know until you start. So what we always say is, hey, listen, we'll send somebody on site for 2 days. We'll talk about a couple of use cases. We'll let you know whether or not you're even collecting data the right way. We'll let you know what you can do, with what you have today. So this relentless pursuit of perfection, that is the stalling mechanism of all of it. And that goes right back to that fear of, oh my gosh, I don't want to mess with the golden goose, right? And they won't mess with it because they'll do anything. So I would say, get started with the data that you've got. See if that data can be joined. See if it can be merged. See if there's any sort of interesting correlations you can get out of that data, and then move into like a preliminary model. If you can prove that you've got the framework to predict something, then at that point it just becomes a math problem. All you're doing is backfilling the data in a way where it improves the model steadily over time. So this has been our technique. Our technique is to get in there and understand the process, reduce the process to a math problem, okay? And then start backfilling the math. So, I can tell you right now, we do some awesome stuff. Right? Listen, of course, I consider us the best in the business. We're doing stuff with Nucor, for example. Again, we reduced steel scrap by 17% in a quarter. I mean, you're doing, 1 million tons a month. I mean, this is significant, situation. And I'll tell you what, it did not start out perfectly. That's for darn sure. None of it did. But when you get to that point where you reduce it to a math problem, mm-hmm. and then you're just backfilling, I mean, that's the point you got to get to. And if you're trying to be perfect from the start, good luck to you.
Are those the kinds of metrics? Like, what I'm thinking is, would love to see the future, right? I just asked you how to get started, but then if you fast forward, what is it like when it's working? I mean, that 17% reduction in steel in a quarter is pretty impressive, but is that typical? Is that common?
Yeah, well, so we like to aim low. So we always say, hey, listen, is there a scenario where a 2% improvement or 3% or 5% improvement?
Phase it in, right?
Yeah, I mean, just give them something that they can say, shoot, this works. There's a clear path for us to improve. So we start by aiming low, but the way it looks like, when it actually really works is you've got those three pieces in the triangle that we talked about before, where you've got an operating margin gain because you're wasting less in the process, you're doing less rework, right? You have a higher degree of throughput because you have a higher degree of quality, right?
Yeah.
So those things they're going to contribute to your operating margin gain by virtue of a reduced cost per unit. And then the second thing you've got is the workforce readiness piece, where people are coming in. Nucor is another great example. Like I said, this one particular thing that we've been doing over there with predictive quality. The training process for that for the Nucor employee used to be 6 to 9 months, and now they figure it out in less than a week. So think about the impact of attrition has now been oh my gosh, we got to pay somebody else 6 to 9 again and train them for 6 to 9 months. It happens in a week now, so that impact of attrition is way lower. So there's a lot of risk that's been mitigated in the business. Right. And then lastly, they can use this at 20 melt shops. So this is something that can scale out where that, let's just say it's $1 million, cost avoidance or money saved in a plant. Scale that out over 20 plants. Now that's significant, right? We're talking 20 million back to the bottom line. So, so just that's what it looks like, when it all finally rolls out. It's clarity, it's process improvement, it's workforce readiness improvement, and it's more money to the bottom line. Competitive advantage in the end.
That's great. Okay, so I have to ask you about your experience as an entrepreneur, as a CEO, as a founder, especially of one in an AI business. As you said, before AI got cool, right? This was back in 2016, 2017 is when you started. And then just to think about the radical growth that we've seen in the interest in AI, the investment in AI. What has the journey been like for you and for your organization?
I feel like I know what it was like to be like a rapper in the early 90s.
We do love rappers in the early 90s. Yes.
Where you're like, man, I'm putting out this art, this thoughtful art that I've, put this blood, sweat, and tears into. And all of a sudden, they got some guy that's just mumbling and he's selling records. Oh my God. So there's a little of that, right? Where there's a lot of market entrants that are considering this a software problem. And this is super important because it's not. Yeah, listen, we have a software platform, but we take a different approach. This is not a software problem, all right? Because what is going to happen when you take a look at changing a process? You're dealing with understanding the process, understanding integration of the change into that process, the people impact, the interface impact. And there's just so much to this, so much understanding, so much nuance to this, that you really got to look at it from a people perspective. So you have to have folks that can get there and communicate, that can speak the customer's language. Manufacturing folks are inherently skeptical of technology at some level. I mean, it's just the way they are. I mean, it's okay. They've worked super hard to create these processes. I mean, and for example, most people think they can walk off the street and just plug something in. That's not how it works. And so this has kind of been this is kind of a wild experience, to be honest, is just to see all of a sudden where, it took us so long to kind of figure out this optimal approach and, and to figure out exactly what the technology needed to do and how it needed to do it. And then all of a sudden you say, oh my gosh, the space is packed now. Like there's so many people in the space saying they can do this. I have to be honest with you. I mean, I would say probably 40% of our new customer engagements, we're coming in cleaning up after somebody. We're coming in, where somebody has made promises about all these big changes, all this industrial AI, all the stuff they can do with AI. And they essentially gave the customer just a different version of what they already had, which is some level of data visualization and some process observations that they couldn't really turn into daily action. I mean, I would say that the big thing we've learned here is that what customers want two things, all right? The number one thing they want is insights. They've got data. Listen, they've got data. And they already know what happened. They can look in the rear view mirror. Looking in the rear, if you have a car and you're driving the car forward, looking in the rear view mirror the whole time is only going to get you so far, but you're going to end up crashing, right? You've got to see what's in front of you. So people want insights that'll help them understand what's in front of them. Then they want actions. They want to be told what to do here in the heat of battle of production. And so when you're able to give them insights and actions, that is the holy grail for what people want in manufacturing from AI.
I totally agree. Well said. Can I ask you about the future? So as a pioneer, you saw AI was coming. What's next?
Totally.
Where are we going next?
Yeah, this is going to be a loaded answer. It's going to freak some people out.
We're ready.
You're seeing a lot of this stuff like Figure AI, the Optimus with Tesla, a lot of these humanoid robots, right? So I think that we're going to see continued investment. So again, this is another leading indicator for our business is capital equipment investment. And so you're seeing capital equipment investments continuing to rise. So of course, people are going to naturally want to maximize the value of that investment. They're going to maximize the value of that investment by taking the data and turning it into something more valuable to the process. And so when we think about this future, this next 3 to 5 years, right? There's kind of three things I would tell people to think about. Number one, you're on a backwards ticking clock right now. If you're a manufacturer and you're not using AI, if you're not a people plus AI business, you're going to be out of business in 3 years. You will be bought for pennies on the dollar. Write it down, put a date on it, come back to me in 3 years, tell me if I'm wrong. I feel very strongly about that. I think that's number one. I think number two is you got to take a look at this new level of automation that's coming into factories. These humanoid robots. The reality is, the human form is probably not the most efficient thing in the world in terms of getting things done. Closed loop automation, certainly more efficient, robots. But you're seeing that a lot of these folks that are like I said, Tesla is going to build their plants and run their plants using these humanoid robots. BMW is doing a trial with the Figure robots, right? So I think this next wave of this future wave is going to be taking the predictive models that we make and turning them into the brain that powers these robots that are performing tasks in the manufacturing environment, whether they're in that humanoid form or whether they're in a closed loop system or in a cobot type of a form. I think that's kind of where we're headed next is how do we leverage this data and turn it into a brain that powers the automated operations within the factory that has context from the ERP system to know where the demand is, to know how much inventory to hold, to know what the production defect ratio is, with the production data, so that they can actually hold true inventory versus being at risk. All these things to understand how weather influences demand, all these like downstream factors. So I think that's the future. The future is this continued development of quality data to bring into an operation that produces a brain that could then start popping out these task orders, things of that nature.
I had said we were ready so confidently, but after that answer, I'm not so sure.
Yeah, there's a lot to it right there. No, a lot to it right there.
Absolutely.
Hey, we're just my life's work. This is what I'm going to be doing until I retire. And that's sort of the thing too that I see, in the industry. And I would warn people about this. I mean, when I said that this is not a software problem, there's a ton of these companies that are funded by VC. They're on a timeline. They're on a backwards ticking clock. Their first principle is to move to the next investment round. I think that people need to reconsider what we're doing here. The first principle needs to be to restore leadership in the American manufacturing plant, right? This is 12% of our GDP. This is stuff that absolutely determines the quality of life that we have, that our children will have, that their children will have. I think that, we got to kind of take a step back here and really get back to the core, to the first principles, which is how do we think broadly about the human experience? How do we think broadly about, what we're doing in the manufacturing plant? How do we go back to creating purpose in the job for the people that are in manufacturing, the people that are running these plants, and the people that are truly influencing the success of our economy?
That's so right on. Well, Rick, we're running out of time, so we should wrap up here pretty soon. But any final thoughts that you have before we wrap here?
I'll tell you, just again, last bit is start now. The backwards ticking clock is a very real thing. I mean, we see it. We're out there talking to probably 20, 30 new manufacturing customers a month. And, the people that aren't engaging, the people that are waiting on perfection, they're the ones that are going to be left behind. The people that are waiting for IT to save their bacon in their process, those are the people that are getting left behind. So I would just say get started.
Yeah, and you gave some great advice too about how to get started. So that's great. Well, for anybody who wants to learn more about Delta Bravo AI or to connect with you, Rick, where would you send them?
Oh, just email me. I take emails. It's ricko@deltabravo.ai. So ricko@deltabravo.ai, and it's Rick Oppedisano. And thanks again for the opportunity, Kerrie.
Oh, thank you. I was wondering if we were all going to have to type your full name into the email, but I love.
I would never proactively give somebody carpal tunnel syndrome.
That's great. Friend. Well, thank you so much, Rick. This has been such a pleasure.
Awesome. Me too, Kerrie. Thank you.
That was Rick Oppedisano, founder and CEO of Delta Bravo AI, a provider of an AI-driven solution portfolio for smart manufacturing. And to everyone listening, thank you so much for being a part of the future of manufacturing.